Good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's 30-minute VitCast, taking the complexity out of securing FPGA IP and data, brought to you by Tech Online, Intel, Arrow, and broadcast by AspenCore. I'm Chris Keach, and I'll be your moderator today. We have just a few brief announcements before we begin. First, the slides will advance automatically throughout the event. You may also download a copy of the slides by clicking on the green folder icon located at the bottom of your screen. You can participate in our Q&A session by asking questions at any time during this webinar. Just type your question into the Q&A text area located to the right of the presentation window, and then click the Submit button. Please note that we'll try to get to as many of your questions as we possibly can at the end of today's program. However, if we're unable to get to your individual question today, someone will get back to you after the program is over. Also at this time, we recommend that you disable your computer's pop-up blockers, and at the end of the webinar, we will ask you to complete our feedback form. Your feedback will provide us with valuable information on how we can improve future events. You can also launch the survey at any time by clicking on the red survey button at the bottom of your console. And if you're experiencing any technical problems, please type your issue into the Q&A text area, and we will be glad to offer one-on-one assistance. And now, on to the presentation, taking the complexity out of securing FPGA IP and data. Discussing today's topic is Mark Frost, Technical Marketing Manager at Intel. Mark is the FPGA Security and 5G Technical Marketing Manager within Intel's Programmable Solutions Group, previously Altera. Within this role, Mark liaises between customers, sales, and engineering teams worldwide for security and 5G communication topics, and works to create market awareness of Intel's portfolio. It's with great pleasure I now hand things over to Mark to begin. Mark, take it away.
Thank you for the lovely intro, Chris. And thank you all for joining today. Much appreciated. So what are we going to cover? Well, I want to give a brief overview of some of the security features available in the Intel family of FPGAs, specifically those designed to protect your IP, your investments, and any data passing through the FPGA. Key takeaways. Hopefully, at the end of this presentation, you will realize that security is becoming more relevant and that we've got some kind of cool features inside our FPGAs that might be relevant to you. Okay, so why is security relevant? I think traditionally FPGA has been quite a niche market, with many organizations simply skipping over implementing security policies. But we're seeing now, FPGAs have really risen in popularity across multiple markets, penetrating lots of different segments they weren't before. And with the increase in cybercrime, we're now seeing that security is becoming much more relevant. And I just tried to find some fairly neutral statistics and some publicly available statistics. If you look at the graph there, this is from the UK government in 2019, where they tried to estimate the cost of cybercrime to the economy in some kind of systematic way. And I think just to highlight there that the two key impacts of cybercrime are IP theft and espionage. Those are the two biggest things. So is your IP, is your data safe from theft? Is your IP, is your data safe from somebody messing around with it, somebody tampering with it? Espionage. So let's see what we can do about this. So protecting your IP, how do you go about doing that? Our Agilex family of FPGAs have got a bunch of different security features built into the device itself for protecting your IP. So things like authentication, so authenticating the bit stream, for example, encrypting the bit stream, and then some black key provisioning to program in any AES key, for example, you have for the encryption decryption. We also support physically encryptable functions for key wrapping and obscuring certain secrets. And then we've got a bunch of things like physical anti-tamper and systems for checking that the ARM subsystem, if you're using that, the SoC subsystem is actually running the right software, so the vendor authorized boot, and things like platform attestation, where you can get the FPGA to attest that it is running a certain bit stream or certain configuration to an independent verifier. Also, we've got a bunch of crypto services as well, and I'll talk about those a little bit later. So how do you go about doing this? Well, the heart of the FPGA, or at least I think the heart of the FPGA, is the Secure Device Manager. So this is a block of hard IP that sits in every Agilex FPGA, controlling all of the configuration, all of the security aspects, and also monitoring any single event upsets as well. So you can see the heart of this is a triple op-step microprocessor, and all the configuration data comes in as normal. So if you're running active serial or a flash or a PCIe interface or JTAG, for example, all the configuration has to pass through this Secure Device Manager, be validated before it goes on to configure the FPGA. From a security point of view, you can see in the middle of the diagram there's a crypto engine. So there's an AES encrypt decrypt engine, the 256-bit key size for verifying the bit stream, but also you can use it for your own purposes later on as well. We've got a SHA-2 hashing engine as well, and elliptic curves for checking the authentication of particularly the bit stream, but also your data as well. There's a bunch of key storage areas as well. So we support PUF, as we talked about earlier. We've got battery-backed RAM and also eFuses for storing the keys. And then there's a bunch of anti-tamper sensors as well, looking at side channel attacks. So you can set this up yourself to configure and respond in different ways, to look at maybe weird things happening with the device temperature or some glitch on a voltage line, or even things like clock frequencies doing strange things. So we've tried to kind of protect the device as best we can, and also your IP and your configuration bit stream. From a protecting your IP point of view, I recommend that you just think about these two things. From all the stuff that I've talked about, these two things are super easy to do and to implement, and it will protect your bit stream, which then protects your investment and your design effort you've put in from theft, tampering, modification, anything like this. So the first one is to enable the authentication, so you can get the FPGA to confirm that it is dealing with a bit stream come from a recognized source, and that it's not been messed with, i.e. its integrity is complete still. Nobody's tried to tamper with it in some way. And also, once you've done that, to enable the bitstream encryption. So to protect the confidentiality of your bitstream, you use this AES 256-bit encryption to protect the data passing in. Then the SDM itself will check the authentication, check the integrity, and then it will decrypt the data and pass that into the FPGA for configuration. Those two things are really easy to set up and do, and I'll show you some document links at the end to get you started with that. Also, we're going to do a little tutorial as well, a little video tutorial on how to authenticate and encrypt, and that will be released in the next week or so on our web pages. So, just switching gears now to talk a little bit about protecting data. So we've seen kind of with the rise of cybercrime, data passing over high-speed networks is becoming more vulnerable. So any kind of networking application, maybe for example, you've got the FPGA doing some kind of switching function, talking to some Internet Things devices, doing some high-speed storage, for example, or maybe operating some kind of communications network. All of these kind of applications of data flowing through the FPGA or being processed by the FPGA are kind of vulnerable to somebody eavesdropping, somebody stealing the data, or worse still, perhaps somebody modifying the data in some way which has not been detected. And so we've got kind of two blocks of IP that have been designed to help protect against this. We have a Symmetric cryptographic engine, and we support the IEEE MACsec standard, both of which running up to line speeds of 200 gigs per instance. So let's look at that in a little bit more detail. So the first one to talk about is MACsec. So this is an IEEE standard, and it's designed really for protecting network traffic. we're seeing kind of with the rise of Ethernet and with Ethernet becoming kind of the connectivity solution of choice. I mean, many applications, vertical markets are using Ethernet of some flavor now. And often these networks are really kind of open. There were some statistics recently, something like 80 or 90% of all network traffic is kind of open. If you stick like Wireshark on it, you can see this traffic and you can read it and you could do something with it if you can access it. So it's really becoming quite important to protect that data, and this is where the IEEE MACsec IP comes in. You can see from the diagram on the right, it operates right down at layer 2 in the OSI model, the data link layer. And so it adds on a very small overhead and can operate at really high speed, particularly for kind of point-to-point type connections. And our IP here will support a 200 gig throughput rate as well. Just talking about MACsec in a little bit more detail. So this was, so it's an IEEE standard, it's IEEE 802.1ae. It's been around since about 2006, and it was ratified as a kind of official standard in 2018, and it still goes through modifications today. But really, to highlight, this is a standard with a long history, and traditionally you'd see this kind of in network routers and switches. It tries to protect the confidentiality via encryption, the integrity, and the authentication or authenticity of the Ethernet data by adding on, basically you see from a little diagram here, it adds on a very small header at the start of the payload, an integrity check value at the end, and then if you've selected to encrypt, it will encrypt the data in between that. So it kind of adds on quite a simple structure to the basic Ethernet packet. If you've chosen to do the encryption, there's a couple of options built around the AES standard in Galois counter mode, and also it supports the extended packet number as well. So it can run at line rate. So this is the nice thing about it. It can run at super high speeds with low latency, and can be used in many applications. So as I said, traditionally that's kind of been used in the networking space, within kind of switches and routers, wireline, network interface cards, wireless access points. But with proliferation of Ethernet, we're kind of seeing it everywhere. So if you're looking at kind of the 5G, the wireless space, interbase station links, the front hall interface, radio over Ethernet, within the data center, so securing data transfers within the data center, and also from the cloud down to external networks. And then also in things like the broadcast space and video, so anything where there's Ethernet being used, retail video, security cameras, video with an Ethernet. We're seeing there's lots of different application areas for MACsec itself. And that's one of the nice things about, I guess, the FPGA itself. It's kind of, we use FPGA for custom applications. So, consider if your application is using any kind of networking traffic, then could MACsec be appropriate to secure the confidentiality and authenticity of that data. From our IP point of view itself, it's supported in the Agilex 7 family of devices. It's a soft IP block itself. It interfaces to the Symmetric crypto hard IP, which we'll talk about in a minute, for the encryption, decryption portion. The IP itself will support a total throughput of 200 gigabits per second in a -2 speed grade device, so the mid-level speed grade device. And it also supports a bunch of the stuff in the IEEE 802.1e specs, so things like packet statistic counters as well. Probably the really exciting part is that it is included for free as part of Quartus, so there's no licensing, no fees, nothing like that. If you go into the Quartus Pro software, search for MACsec, you will see that the IP is there, fully available for you to use today. We've also got a bunch of designs, example designs to try and get you going. So in the IP itself, there's a nice example design that you can get running on your board, shows how to instantiate it. And then we've also got some system level example designs. So we've got one available now with an example running a full duplex Ethernet link with an optical loopback cable and some software running on a Linux machine to set up the keys or doing all the key management. 25 gig full duplex, and then there will be a 100 gig full duplex design later on this year. So those designs will be ready. We'll have some tutorials, some videos showing all this kind of stuff as well. It's actually pretty easy to implement. If you go into the Quartus software as well, it's just a simple drop-down menu. There's a few little things to select in terms of, do I want these packet statistic counters? Do I want this IP to do encrypt and decrypt mode, or does it just encrypt on its own? Number of ports you need, this kind of stuff. Fairly straightforward to set up, and you can just instantiate it very easily in your IP. Okay, so let's talk about the encrypt decrypt, the cryptography side of things, AES crypto engine. So this, in this case, is actually hardened IP. So in the Agilex 7 devices, there'll be 2 or 4 of these blocks. Each of those blocks can support 200 gigabits total throughput. So you can get up to 800 gigabits in some devices, which is kind of more than sufficient for pretty much any application today. So it's hard IP wrapped with a little bit of soft IP for doing something like the map packing and integrity check value comparison, doing some reset sequencing and some interface adapting. But the guts of it is hardened. It supports 3 modes. So we've got the AES Galois counter mode up to 256-bit, and we've also got the AES XTS mode up to 512-bit, which is typically used for kind of storage applications, high-speed storage type applications. It also supports the SM4 mode, which is generally used in China. So as I said, it kind of plugs together with the MACsec IP. So if you instantiate the MACsec IP, it will expect to have a device with the hard crypto engines in to talk to. So that interface is seamless. But, this IP, and we see customers today using this IP for any kind of encrypt or decrypt application where they've got some high-speed data passing through or being processed by the FPGA. This IP can be used to protect the confidentiality of that data. The IP itself actually comes with 4 predefined profiles as well. So if you are using MACsec, you can just select, I've got a MACsec profile. Maybe you want an IPsec profile as well for layer 3 in the OSI model. Or you can just use it in the generic modes as well, like generic GCM mode or the generic XTS mode. Much like the MACsec itself, it's available in the Agilex 7 devices. Mid-speed grade device, so you don't need a very high-end, high price speed grade device. You can just pick a mid-speed grade device for 200 gig throughput per instance. The other nice thing is these have all been now validated by the US government CAVP program, the Cryptographic Algorithm Validation Program. So the government has taken a look at this and said that this AES engine is fit for purpose and it meets their criteria. Again, it is free as part of Quartus, so you don't need to pay any licensing fees. It's available within the Quartus software itself. Just go and search for Symmetric Cryptographic IP. The IP will pop up. The only restriction we do have for export compliance is getting access to the simulation models, but that's pretty easy to sort out. You just raise an IPS case. It describes how to do this in the user guide, and then we can give you access to the simulation models if you need it. The IP itself also comes with a really nice example design, so you can get going quickly, and it supports up to 9 different profiles, mixed traffic, all this kind of stuff. Much like the MACsec as well, super easy to implement, single IP configuration screen, just a few drop-down boxes to select a few options that you might need, which mode you want to operate it in, this kind of stuff. So again, very easy to use and implement. And then finally, some kind of highlight of what we've got in terms of documentation. So probably the best place to get started if you're interested in looking a bit more at this is just to go to our webpage or just do a Google search for Intel FPGA security, and there'll be a bunch of stuff there. there's a newly published MACsec webpage. Again, search for Intel FPGA MACsec. And the same for the Symmetric crypto as well. So you can look on there, tell you a bit more about the IP itself, how to get hold of the IP, where the user guides are, this kind of stuff. We've also got a bunch of tutorials I've talked about later on. I'm kind of a big fan of videos, how-to videos, do that kind of stuff. So we're going to get some of that filmed. Excuse me. And then there's a bunch of, as I talked about, the example designs in Quartus. And then there will be the system-level example designs we talked about earlier. So I know we're kind of short on time today. So Chris, back to you. Do we have any questions?
All right. Thank you, Mark, for a great presentation. Yes, we do have some questions. And if you'd like to ask a question, we're going to move on to the question and answer portion of our event. As a reminder, to participate in our Q&A, just type your question into the text box located to the right of the presentation window, or you can click on the Q&A icon at the bottom of your screen. Type your question in, and then click the Submit button. Please note that we'll try to get to as many of your questions as we can here in this 30-minute session. If we don't get to your individual question today, someone will get back to you after the program is over. So, Mark, we've got a couple of questions coming in. Our first one, what industries are most interested in the MACsec and crypto IP?
Okay. Yeah, so we kind of covered some of that a little bit during the presentation, but I think the bulk of the interest comes at the moment in two areas. So one is, the wireline space we talked about, the kind of networking space, where we see a lot of interest from customers using this IP to secure that network traffic. And then we've got the interesting case of 5G itself, particularly in the front-haul interface between the radio unit itself and the baseband unit. That interface has become kind of Ethernet-like, and there's interest in some customers in trying to secure the traffic on the interface. So that front-haul interface itself is being secured. Now, it's not actually ratified in the ORAN specification yet, but we think it may well be at some point, and in which case we'll see more adoption in the 5G space of MACsec particularly. But I guess that's one of the beauties of the FPGA. It is a kind of custom thing. So just think outside the box on this stuff. We see so many customers doing super cool stuff with their FPGAs, and then maybe some of this traffic that they're processing could use some of this MACsec and crypto IP.
All right, thank you, Mark. And do you have any more details on the MACsec example designs?
Yeah. So these have only just literally be completed. So there is a really detailed user guide available, which shows how the IP has been instantiated. And they've tried to do it in a representative way that you would use MACsec in an example yourself. So not just kind of a very standalone way, like how would you actually instantiate this IP in a real-world design? How do you manage the keys, which is another part of MACsec? How do you manage the key agreements, getting the secure keys transferred to the IP? How do you manage all that? So we've got some Linux applications showing how to set the keys up completely. So they are available today, or the first one is available today on the Intel Resource and Design Center. You can search for that and it should come up, and you can download that. And so I said that's a 25 gig example. And then later on this year, we'll have a 100 gig full duplex example. And I'm hoping to get some videos recorded with somebody kind of talking through the IP and showing how it's running and how you set it up, and showing it running on a board. So you can kind of get a nice flavor for what's happening.
All right. Thank you, Mark. It looks like we have one more question for you. Our final question, is the Secure Device Manager available in other FPGA families?
Okay, so I've kind of focused today on our newer devices, the Agilex family, which is the Agilex 7, and then there's Agilex 5 later on this year. But actually, the Secure Device Manager was in some earlier devices. So it actually first appeared in the Stratix 10, I think back to 2014. So we've kind of had it, we've kind of bet the house on the Secure Device Manager a little bit going forward into this kind of mid-range, high-end FPGAs for all the config and security stuff. So yeah, it's been around for a while. we've had a nice track record, and it's kind of been refined and improved over that time as well. So we're pretty happy with it.
All right. Well, thank you, Mark. That does look like all the time that we have for questions for today. Once again, if we didn't get to your individual question, someone will be getting back to you after the program is over. I'd like to thank Mark for a great presentation and Q&A session. And for more information related to today's webinar, please visit any of the resource links available in the green folder icon at the bottom of your screen. Within the next 24 hours, you will receive a personalized follow-up email with details and a link to today's presentation on demand. Once again, we'd like to thank you for attending today's Bitcast, Taking the Complexity Out of Securing FPGA IP and Data, brought to you by Tech Online, Intel, and Arrow. And this webinar is copyright 2023 by AspenCore. The presentation materials are owned by or copyright by Tech Online, Intel, and Arrow, and the individual speaker is solely responsible for his content and opinions. On behalf of our guest and also Intel and Arrow, I'm Chris Keach. Once again, we'd like to thank you for joining us, and we hope you have a great day.